Okay, so let us look at this one. So for each of the following random variables, find px is greater than 5, px is greater than 2, and less or equal than 6, and the px is greater than 5 given that x is less than 8. It said that you don't need to provide the numerical values for your answers, right? In other words, you can leave your answer in form of the sums, given that the range is this. Okay, is this. All right. So let's take a look. What we can see. So for the first one, well, let's look at those three inequality probability. When the probability x is greater than 5, do you see it equal the probability of 6 plus, right, 7, etc., right? So in other words, we can use the summation when k is starting from 6 to infinity, p of x equals k, right? So that's the equivalent form, because we're going to use that. Second one is x is greater than 2, less or equal than 6. Since our range is given, right, so that is the probability of x equals 3 plus x equals 4, x equals 5, and then plus x equals 6, right? So we can also write it as a summation, which is k from 3 to 6 equals k. Okay, that's this. Now the other one is p x is greater than 5 given that x is less than 8. Okay. So based on the conditional probability that is greater than 5 and less than 8, and then less than 8, right? So you can see on the top, x is greater than 5 and less than 8, so you're going to only have 6 and 7. And then this one contains a lot. So the sum k is from 0 to 7, p of x equals k. Okay, so yeah, so that's the interpretation from the problem first. Okay, so now we want to take a look at, okay, what about, those variables, they follow different distributions, right? What is going on? Okay, what is going on? For geometric one, very different. Okay, very different is the range for the geometric is gonna be 1, 2, 3, 4, 5, 6. In other words, it does not include the 0 part. Okay, 0 part. That's something what we can tell. So going back to here, part 1. So x is following the geometric fifth. So the PMF is going to be p x equals k, so it's going to be 1/5 times 1 minus 1 over 5th to the power of k minus 1, right? So k is from 1 to 3, So that's something we can tell. Okay. Moving back to this problem here. So you see, we can easily to drive that, right? So for the first one, px is greater than 5, which is going to be the summation of, let's use k, okay, k from 6 to infinity is going to be 4 over 5 to the power of k minus 1 times 1 over 5, right? So yeah, so that's the first piece. Second, px is greater than 2, less or equal than 6. Of course, we can write it down, right, into k is from 3 to 6, and then so it's a 4 over 5 to the power of k minus 1 times over 5. It's also easy. The third one, a probability that given, this is 8. Now you need to be very careful, because when I drive those general expressions in terms of summation, I assume that the range is starting from 0. But for a geometric one, you see the range does not include 0. So when you try to write it down here, the denominator starting index for summation is going to be starting from 1 instead of 0. So just to be extra cautious about this part. So the probability when x equals 6 is 4 over 5 to the power of 5 times 1 over 5 plus the 4 over 5 to the power of 6 times 1 over 5, and then over, you know, the bottom one is the summation when k equals 1 to 7, right? So it's k minus 1 times over. So this is 7. Okay. So yeah, so that's the first piece. Okay. Again, there's really no need to do the calculation. Okay. So okay. Okay. So when we have okay, so that's the first part we're doing with the geometric one. Second, let's see if we got another paper. Second, it's using the binomial. Okay. Binomial is what? Binomial is, for this example, it's a 10 and a third. That means you toss a coin and then 10 times. And then x is the random variable, stands for the number of the head you observed. Okay. And then for the so 2x is following the so that distribution px equals k, which it's going to be a 10 chooses k, right? And then it's 1 over third to the power k times 2/3 to the power 10 minus k here. You need to be, again, be very careful, as k here is going to be 1 from 0 up to 10. Okay. In other words, you toss the coin 10 times. It's also very possible that you don't get any here, right? So 10 of them are our twos, although this is very, very rare. Okay. Okay, so let's take a look. Moving back, you see the probability that x is greater than 5. Don't you agree that it is include all the cases, k from 6 to 10, right? So it's 10 chooses k, 10 minus k. So that's that. Because when x is greater than 5, you only have 5, 6, 7, 8, 9, and 10. That's it. Okay. 2, so it's greater than 2, less or equal than 6. So again, so it's k is from 3 to 6. 10 picks k. That's it. Also simple. 3 p greater than 5 q. So this, if you wrote quote, what we already derived here is in this, right? So basically, when so look at this probability of 6, 7 over the summation here. So on the bottom, it's k from 0 to 7, 10 chooses k. Okay, that's simple. And then on the top, it's going to be when x equals 6. Plus 7, right? Yeah, that's it. Okay. So that's binomial. Third one, when x follows a poisson 5. Okay. So the poisson distribution, it measures the for example, it's kind of like it measures the number of happiness at a certain moment. For example, if you want to observe, the number of the people in an airport, let's see, from 1 to 2 p.m. And based on the previous data, you find that on average there are, 20,000 people will come from 1 to 2. And then the Poisson distribution, it asks us, okay, what is the probability that there's no people come to the airport between 1 and 2? Okay. What is the probability there's 1? What is the probability there's only 2? What is the probability there's da da da? Okay, something like this. So that is what we call, the Poisson distribution here. And since this lambda equals 5, so the corresponding probability is e to the power of negative lambda times lambda to the power of k over k factorial. Okay, k factorial. And for here, again, k is from 0, 1, 2. Okay. So all the non-negative integers. So with that in mind, we can just write them down. So the probability of x is greater than 5, again, summation k is from 6 to infinity, so e to the power of negative 5, 5 to the power of k, over k factorial. Okay, that's the first piece. Second piece, it's greater than 2, less or equal than 6, Okay, so it's the summation. K is from 3 to 6, e to the power of negative 5, 5 to the power of k over k factorial. Okay, again, there is no need you do any computation here. Number 3, what is the conditional probability of when x is greater than 5, given that x is less than 8? Well, when x equals 6 and 7, so 6, so 5 to the power of 6 over 6 factorial plus 5 to the power of 7 over 7 factorial over the summation k from 0 to 7, right? So it's going to be e to the power negative 5, 5 to the power of k over k factorial. Okay, so very bad handwriting, but you get the basic ideas. Okay, so hopefully you enjoy this problem. Okay, so thanks.